Cardstack community. I'm Chris C., the founding director of the Cardstack project, coming to you from the land of the Web3. Welcome to another episode of Web3 Watch. Today, I'm joined by dm3 CEO Steffen Kux, who's going to talk about decentralized messaging, especially as it relates to the Web3 world and the value creation and the human on the other side, and how do we bring them together so that we're not just talking about assets and numbers, but we're actually building a social structure and this type of real-time coordination in addition to the capability that I think we're all seeing more and more need for, which is a decentralized way of coordination. So welcome, Steffen.
Hi, thank you for having me here.
Yeah. So really excited to talk about this topic because I think a lot of the conversation about Web3 is, what else can we do beyond tokens and NFTs? And there are a lot of research projects and different projects working on extending the decentralized web or Web3 infrastructure beyond just the asset part, trading, and then getting into things like coordination, and obviously messaging is one part of that. Can you tell me a little about your journey in Web3 and what kind of drove you to working on this idea of direct messaging or Web3 messaging?
Yeah, when we talk about messaging or dm3, so it starts actually about 1 year before. So we were building our new company, Corpus, a venture studio for Web3 applications, and we tried to acquire some ENS names. So they are available at OpenSea as NFTs, but what we could not do is to reach out to the owners of them. Now, we could bid a place, but we could not send a message to them. So, and this was actually the birth of dm3. We thought with Web3, we have all these keys, we can do a good cryptography, we can share public keys for encryption. That's easy. And it must be possible to send a message directly from me to any holder of the other key. And this was so the idea behind dm3. And we started building a protocol, and in the beginning also an application that we can do this. Yeah, and after a while, we discovered there are a lot of other Web3 messaging protocols out there. And what we really need is not a new messaging application, but what we really need is that we can be interoperable with others. Now, when we look at the messaging world today, now in the Web2, we have all these different messengers, and they are siloed. They have siloed data, and if I'm part of one ecosystem, I can use, or I have to use the messenger which is used in this ecosystem. But if you
the classic debate of iOS and showing up in a different color within Android or vice versa, right? Like that's not really compatible, really.
Yeah. So if you look at your smartphone, at least at my smartphone, I have at least 10 different messaging applications. So one I need for my family, one for my colleagues, another I use for people in the Web3 space. And so it is really complicated because we have to use these different messaging tools or messengers. And what would be the best thing to interact with others? The best thing would be I use the messenger I like and can send a message to anyone else.
Right. And are you talking about like the goal of a federation of these messaging protocol where the addressability within one network, let's say someone using WhatsApp or something like that, or someone using Discord or someone using XMTP, can actually have a way of contacting each other? Is that the ultimate goal?
Yeah, so when we look at these ecosystems now, of course, they have all special features which are good for these ecosystems. But what they cannot do is to send messages across the borders of these ecosystems. And this was a reason why we changed a little bit the direction of our development, so that we not only build another messaging solution, which is one in the row of a lot of others, but to build a protocol and a way to get interoperability possible, starting in the Web3 world, but also with the chance to adapt it in the Web2 world as well.
Yeah, that makes a lot of sense. So, in Web3, there's been kind of discussion of the similar drive of the use case. I think NFT use case is very obvious, right? You have a opportunity to know that someone owns something and you want it, and right now, unless they list it or somehow otherwise participate in some other kind of secondary marketplace or sharing point, there's no way for the direct messaging. I mean, you can send a transaction and put a message in the transaction somehow, but nobody's reading that other than some like traders who are like, kind of researching Etherscan. So what is your sense of the kind of adoption of the messaging protocol within the Web3 space? I wouldn't call them necessarily competitive, but, with your vision bringing them together, like project like XMTP, what is happening on with Wallet Connect, kind of extending their install base on the Wallet Connect QR code synchronization to have a chat protocol. Do you see those as in the right direction of where we need to go within the Web3 space? Or do you think that this should be a different direction?
Yeah, first of all, you mentioned something very important. That you will never use the blockchain to do messaging. No, of course not. Because this would be slow, it would be very, very expensive, and it doesn't make sense at all. But we have a lot of Web3 technologies which are very good to use for messaging. Now, for instance, we have keys. Now, I have my wallet, and with a signature of my wallet, I can create a key or can adapt a key, which I can use very securely for my messaging as well. So, and for this, I don't need any centralized intermediate who stores my connection data, or I need to have an account somewhere. I have my wallet, and I derivate from my wallet the keys for my communication. And then I need to publish the information how to encrypt my messages and how to contact me. And this is actually the essence of of our analysis. What is really needed for a secure Web3 communication? Now, there are a lot of interesting things and not a lot of very important parts of it, but the most essential part of this is you need a place where you can store the information, how to encrypt the messages. You need to publish the public keys, and you need the information how to send a message to someone else. And this is actually the base core of the dm3 protocol.
Right. Those three things, right? I mean, is it three things? About three things, right?
You need this place where to store it. You need the place where to store the information of the public keys. And you need information how to deliver a message.
I see. So storage of the keys and the delivery, which is, again, in the Web2 space, a company like Keybase was attempting to do those things, which is the kind of deploying this idea of being able to look up these keys. And then I think they then, go beyond just being a key storage, and they actually kind of productize into a messaging thing as a way to use that key system. Neither of them worked. So I think that doesn't exist anymore.
So when we look a little bit back in the history of messaging or the internet, we see the very first killer application in the internet was email. It was a kind of decentralized service, and you had this post office service, also your web server, where you could send the message to, or could receive messages to. So the thing which was not good with email was it was never encrypted. So
by default, it's just clear text for all to see. Yeah, it's quite crazy if you think about it.
Later on, there was a lot of tries to get encryption into email as well. Now we had the PGP initiative, and I don't know if you use these PGP keys. I did it. I tried to send my public key around with my emails, but guess what? I never received an encrypted message back. It was not easy to use. And actually, it was not possible to find out what are the public keys of the recipient. And that's why what we really need is a central registry of this information. And with dm3, we have now used Web3 technologies to provide this central registry. We are using the ENS name service as this central but decentralized registry. And we have a central place where to access it, but the application, of course, is decentralized.
Yeah. And I think it's really interesting, right? People are already using ENS as a way to convert between the human readable name and the addresses. And the key, the public key, in fact, is just similar to length and structure of the addresses, maybe a little bit different based on the encryption protocol. But from a presentational point of view, they're kind of the same kind of process, right? You just put it out there and people see it, and then now they have the ability to message you.
Now, the only thing what we need to do is to add the public keys of the encryption and also public keys to verify signatures to my ENS name. ENS provides a way that we can store text information and we can add an additional text information, which is the dm3 profile. And in this profile, we can store these public keys so that it's easy accessible from others.
Yes, and it's really interesting that once you say I'm going to use ENS for that, then you can have a conversation about whether the ENS is on mainnet, and obviously most ENS are on mainnet. There are something about having sidechain I don't completely understand, and maybe you can give me a little bit. But I also am interested in the Coinbase model with the cb.id, which is an ENS subdomain that is kind of like hosted in the database but exposed through the ENS protocol for people looking up that thing. So it seems like there's different ways, even within the ENS protocol universe, of where that stuff can and how it can be delivered.
Exactly. This is the very important point. Good that you mention it. So, of course, if I have my ENS name, for me, I have my name, I use it, and then I can store my public profile on my name. This is transaction. Actually, it's not quite cheap. When I do it on mainnet, I have to pay a lot for this transaction.
Yeah.
And when we
for the update, right? Like for the actual updating of the key, the publishing maybe costs you $20 to $50.
Exactly. Yeah. When I send my or update my dm3 profile in my ENS name, this costs me a lot of money. So, and of course, this is good if I want to use my name, but for mass market adoption, this is quite not usable. And you mentioned already that there are other ways how to do it. Now we can use layer 2 solutions. So, for instance, we could use Optimism, Arbitrum. These layer 2 roll-ups we can use to store the information there and then link it to ENS. So what we are using for this is CCIP, the cross-chain interoperability protocol from Chainlink. And with this, we can have validatable information which is not stored on-chain. We can get the information, then of course we cannot get it from chain, then we get the information where to acquire it off-chain, and then we get the information and the proof, and this together we can prove on-chain. And so we can get the information from directly layer 1, we can have it in layer 2, we can have it in any sidechain, and even we could have it in a centralized database linked with the same mechanism to ENS. So from the ENS perspective, it looks completely the same. The only thing what you have different resolvers, and one resolver gets it from main chain, one resolver from layer 2, like Optimism, another gets it from a centralized solution.
Yeah, I think this whole layering of the name, so like the ENS name for itself, it does make a lot of sense for those assets as their like domain name to be in this more expensive but rarely transacted namespace, and therefore paying $40 to transfer ownership of a very valuable 5-digit or 5-letter ENS ETH.ETH address makes sense. But for these ongoing updates, it's always, to me, seemed a little bit weird that, oh, here's my bio. Am I going to change my bio for $50 just because there's a text record on mainnet? So I think it's a really good thing to have this idea. But I think the using the ENS as the resolver and as a protocol, as a way to access all this information, hopefully the ENS can provide that facade, so it doesn't matter where that information is coming from. Is that actually possible right now without some special SDK to actually use the ENS client SDK to get this amalgamated information?
Absolutely. This is live, and we are using it.
That's awesome.
So we have, we are of course using layer 1, but we also now have developed a resolver for Optimism. We have also developed a resolver for centralized data so that it can be very easily integrated.
That's really cool. So you mentioned two key components. It seems like we have a pretty good way of leveraging the ecosystem investment in ENS and kind of operationalize that infrastructure in a way that is not only secure but also efficient. Cost efficient, right? Yeah. So that's that. As far as the delivery of the messages is concerned, what do you think is the main issue, right? Like, Federated Network has this the challenge of saying like for example, people using these Mastodon or something like that, like they can't take an action on the server because the server has that protocol. You have to add it in your own home server. So there are some friction with federated systems. In the particular approach you're using, are you saying that everybody goes to my chat server, or like essentially host a chat server, but you end up owning your data that you created, your chat messages and your relationship? Or is it a model that's even more federated than that?
Let me explain how we have designed it in our protocol. So actually it
Okay,
is a
that's
little
cool.
bit similar to how it was done with email. So we call it a delivery service. So a delivery service is a service which can receive messages and stores the messages as long as it is not required from the receiver. Now, if the receiver picks the message up, then the delivery service can
Right.
delete the message. It's only a relay for the messages until they are delivered. So, and these
see.
delivery services, they are, of course, services which also can be a break. And if I would only have one delivery service, then I would have a centralized system, which is not what we really want. But it is
Right.
possible that everyone can run his own or her own delivery service. I can run it at home at my dev node, or I can use a delivery service which is provided as service, so that the user can decide what is the best delivery service or what are the best delivery services I want to use. And
I
with
see.
this, we don't have any single point of failure. Yeah, there's no censorship possible because the user can decide what delivery service he wants to use. And if he
Right.
thinks this delivery service is not good for me, he decides to use another one.
What's interesting about it is that this is not exactly the same as a compromise we did with the Post Office Protocol or POP3, which is a delivery service. Because of the domaining system, it does affect your identity, right? So if I'm going to be at a university and I'm using the university as my delivery service, I also have an identity tied to my name at university
Exactly.
ac.uk or edu, whatever it might be. In this case, we're saying the delivery service is only serving as a buffer. My name is separately defined in the ENS thing that we just discussed.
Exactly.
Is that the
Exactly.
difference?
So I have my name, for instance, sdcooks.eth, my ENS name, and here I have
Yeah.
published my information. So, and I can also have a subdomain it must not be a level or a first level domain name. So, and this is my communication information. If you want to send a message to me, you would go to this ENS registry, look up my dm3 profile, and here you will find a list of the delivery services I'm looking up. And that's why
I see.
it's completely decoupled. I don't need to rely on any service of these delivery services. Now, as I said before, I even can run it at home on my home server because there's not that much traffic on this service. It only has to manage my own messages.
Right. So delivery services are kind of like a post office box in the way that's underneath your commercial building or apartment building. It's just accumulation of what has not been delivered, but not has been received. So you go collect those things, like, oh, that's my 15 messages I was offline or otherwise not available from this delivery service. When the user take that information and say, this is the last 10 message, what happens afterwards? Where does that message go? What is the permanent storage place for the messages being pulled off these kind of like, relay or delivery service or supernode, however you look at it?
So actually, this really depends on the client behind it. So maybe I have to add one more information to the delivery service. A delivery service can also act as a gateway to any other protocol or service. Now, for instance, if there is another protocol which wants to join the dm3 ecosystem, it has to run at least one or more delivery services. And then if a message is sent to this service, it is taken and then injected into this network or however this service works with messages. And with this, it is very easy to add other protocols or other services, other applications to the dm3 ecosystem. And this is the part where we think the interoperability comes to life. Nobody needs to completely replace their own protocols. They just have to build these gateways own delivery services so that they can access these messages sent in the dm3 network and then bring it to their own network or to their own service. It could be a
Right.
decentralized network, it could be a centralized service. We don't care because the delivery service of this service knows how to publish the message in the other network.
Right. And there's no reason the actual message has to be just like a hi or message. It could actually be a structured thing. Like I can be delivering a request to buy something with an offer signed on it, right? And you can accept it if you send it back or something. That's certainly possible, isn't it?
Exactly. So the good thing when we're using this kind of messaging, we have the information how to encrypt it, and the receiver also has the information how to verify all the signatures. So every information is fully end-to-end encrypted, and every information is also signed so that the user can verify at any point that it's coming directly from the sender who was the sender of this message.
Yeah, that's really cool. In the email, the regime, we know that the POP3 protocol, which is the post office protocol for the day, end up being that people get so lazy that they say, you know what, I don't even want to manage my own mailbox on my computer or on my node. I want to have the service in the university case where you want to access a mailbox, allocated space for it. So that in a way is another protocol, like the ability to filter or search on the server on the thing is just adding that protocol layer on top of that delivery service.
This is a protocol extension we also have in dm3. So dm3 is a big package of different protocol specifications. We have this message transport protocol, what we discussed now, which is the very base. With this, we can do the interaction with others, with other protocols, other services. But then we have also a specification how we think message storage is best accomplished. There are different ways how to store these messages. I can do this completely locally. If I don't trust anyone, this would be the best approach. Or I can use also a service where I store my messages in an encrypted way. Then I have a kind of centralized storage. I can use decentralized storage if this is the best thing I want to do it. Or I can store it in the cloud, on a cloud drive, for instance. Now, if I'm using Apple and I say, okay, I'm fine with it that I store my communication information encrypted on my Apple drive, that's fine. So we think the user must be able to decide where and how to store these messages. Now, he needs the self-sovereignty to decide how to interact with these things.
Yeah, it's interesting to think about the actual mailbox information, which is the accumulated history, as an encrypted blob, where you need that key, which exists very close to the user. So that's where the Ethereum, EVM key comes, not EVM, Ethereum key, public keypad comes in. We've been working on these kind of similar problems, and one of the things we realize is that the long-term storage of these things can be in many places, especially as encrypted. But indexing, allowing people to search for who sent me something, did they say this word, that requires the decrypted version. So like you can't search an encrypted thing. So if someone has an encrypted storage in iCloud or in a proprietary SaaS database, they can't offer you a search service because they can deliver it to you and your client can decrypt it, but they don't have ways to look inside it. Do you think that is an issue, or is that something that can be solved somewhere?
Yeah, the client will be responsible for indexing these messages.
I see. Client has to be indexed.
We cannot delegate it to any server because the server will not have any access to this. But the client can have, and must have, of course, a way how to index all this information so that the user can search on it. But nobody else will have access to it.
Yeah, it's interesting how little client-side indexing we're seeing in dApps. I think a lot of dApps that's being built in this space are backed by some graph services and some additional database that they do, and then they do the signature on the client side. But the indexing on the client, whether it's the browser or like a native application, has not been something that is very popular yet, because I think they didn't need it so far. Maybe some wallet does some indexing in the React Native code or something like that. But generally speaking, we're still in the world where the dApp does a lot of the amalgamation of data on behalf of the user. But yeah, for encrypted communication, we cannot rely on the graph or subgraph. That's just crazy.
Yeah, of course, you could outsource this process to a server application, to a backend application. If you think, okay, that's fine for my communication, or maybe you run this indexing service on your delivery service node, which you have on your home server, then that's completely fine. Now, you don't need to do this in the browser or in the smartphone app. Now, you can use it in an external service, which is only managing your data. But what you can and don't want to do is that to open this communication that someone else is doing this for you and adds your index to all the other information. How it is now done with Google and others.
Yeah, I think that it's very, very, difficult to provide that type of service that Google has made. Oh, I can search all your Gmail record. That type of stuff is somewhat incompatible. Now, with that being said, a lot of work can be done in client-side indexing. In fact, in Cardstack, we're doing a bunch of indexing in using Service Worker, which is a way of running back-end programs that would have run on like Node.js, but in your browser, and do the indexes by information that comes to your browser, and we essentially build a database on that, and then it's giving you that things. Now, we weren't using for encrypted communication. Information is for kind of like as you're drafting something, creating a thing, we have a place to store them and let you find the thing you were working on before. Let's say you're making a payment or orchestrating a series of multi-transactional call. There's a place to store that as you compose them versus closing your browser and losing it all. So it was for that purpose. But I can definitely see that particular type of client-side persistent indexing being really compatible with the protocol as opaque in the relayer, but eventually it needs to be decomposed. But it's the only safe place to do it is probably your browser. Especially with the protection that the browser brand that gives us.
Maybe the browser is this is one case. Now, of course, you should have a desktop application or a web application or a smartphone application. So there are different types of applications you will have to make your messaging a good experience.
Yes. And then certainly with a wallet in a native sense, then you have a database there, and that could be where it's been done. Kind of zooming out a little bit, looking at there's obviously a lot of discussion about the methods of doing decentralized messaging. Obviously, the granddaddy of decentralized messaging comes from the Status team with the work they did originally on Whisper using the Grand Trio protocol, the Ethereum EVM stuff, the Whisper. And then the storage protocol, which I don't know what it was called anymore, but one of them. Swamp, yes. I think IPFS and Filecoin in a way is satisfying that, and then Whisper has become Waku, and Waku V2 is still under active development. Do you think those protocol are complementary to what you share with us today, or do you think they are competitive?
I think both things. So, of course, they have some things which are very unique to these protocols, and they have their use cases. So when we were thinking about dm3, we also are thinking about what is needed to be scalable enough to manage messaging in a big scale. Now, when we look at common messaging solutions, they are sending millions and billions of messages per day, edit with pictures, video content, and so on.
Facebook Messenger, Discord,
So when we look at this is a really big amount of data we have to carry on. So, and scalability is a very essential part of messaging in the future. Now, we cannot say, okay, let's build a solution. It is very secure now, privacy preserving, and scalable. We will look at in the future.
10 years.
We don't think this will work. And with the network or with the approach of dm3, we have a scalable approach from the very beginning. Because these network or these delivery service network nodes, they are not connected directly. They are not sending messages to
Right.
each other. This is a
Right.
loose network of
Right.
nodes. And if I need more bandwidth, I can add more nodes. And in this way, it scales very easily. So, and if there is an application using another protocol, as I said before, that's not a problem because dm3 is not a replacive protocol. Now, we don't want to replace other protocols or services. We want to
Yes.
integrate. So with this approach, you have this central registry in ENS, and you have these delivery
Right.
services
Right.
which
Right.
can act as gateway to other protocols. It's very easy to add other messaging protocols or services to this dm3 ecosystem.
Yeah, it makes sense. And I think, when we think about peer-to-peer messaging protocol, the first thing is let's take the chatter that is coordinating all these block mining and use that as the messaging foundation. But if that is used for the billions of messages sent a day, the chatter will completely overwhelm any system because of the inefficiency of using peer-to-peer gossip, for lack of a better word, to coordinate just discovery of who anybody is, right? Like that seems expensive to me.
And there might be some problems in the future if we have a lot of messages. These nodes must be very, very powerful. If you receive
Yeah.
1 billion messages per day with attachments and so on, and you have to
Yeah.
send it across a network, then this is a lot of data you have to manage. And that's why we think,
Absolutely.
yes, there are really good use cases where this is the best approach to do that. For sure. So, but
Yeah.
dm3 has, we have the goal to look a little bit wider, how to connect all these ecosystems. And that's why we think interoperability is really the key feature for the future, so that it is not necessary for the user anymore that he has to run a lot of different messengers or for an application to provide access to several protocols, because this blows all applications up. And if they have only one interface, one small interface to implement, and then be compatible to all others, then this is a very good approach to make scalability possible.
Yeah. And I think it's nice that the part that would have been the chatter is just finding out where someone is and what node they want to use and what protocol want to use. And ENS, which is a kind of a decentralized solution to a centralizing architecture, which is there is a central place for you to find it, is actually much more powerful than just a very valuable 5-digit ETH name. So I think there's a misalignment of the technology potential of ENS being that centralized, lazy architecture with a decentralized implementation versus just trying to continue the gossip protocol approach, which is really two very different starting point of a solution. And I see what you did there. You're saying I can achieve the same decentralized messaging goal starting from another end, but traversing the ecosystem like ENS and CCIP in a way that other people starting from gossip in the protocol synchronization level would not do that. Am I characterizing this roughly correctly?
Yeah, of course, there are also some backsides. Of course, with a gossip protocol, you can do something which is not built in dm3. Now, for instance, to have a deniable receive of a message, it's not built in directly in dm3. Now, if I could monitor a delivery service, I would see someone has sent it a message and another one has picked it up. And with this, we would have this metadata connection. No content is revealed, but I have this connection.
Yes.
And for this, of course, we have also another protocol extension, which we call the privacy extension, so that we can use delivery services in the same way like the Tor network is used, that you cannot send or will not send the message directly to the receiver. You will send it to another delivery service, and you have some envelopes packed in each other, so that it will be sent to a delivery service, this redirects to another, and so on. And after some hops, also we have a complete decoupled sender and receiver relationship.
Right. I see. So instead of being like the nature of the gossip protocol where a bunch of messages are flooded into the channel and you pick up what you want, you basically say, well, we have a more directed channel, but by doing a sequence of relays and somehow opacity that comes with a design similar to Tor, you achieve similar privacy
Exactly.
goals. That's really cool. And I think the question I have for you is, like, I completely get the approach and how it's different. I think one of the challenge for most people, especially if they're not technologists, understanding Web3 is that a lot of similar sounding words from a end user point of view has very different philosophy and different trade-offs. And the trade-offs sometimes don't come through in either marketing material or memes or tweets or even Discord messages. And even in GitHub, like things look more the same than they're different. If you have a React project, then it looks more the same and you have to really dig in to see the subtle differences. I'm glad we're able to talk a little bit more kind of broadly. Tell me, like from a use case point of view, obviously regular messaging that inspired this thing, it's like messaging a NFT owner, in this case an ENS owner for a deal is one use case. Are there other use cases that if these extensions are in place and people have wallets that can generate these message encryption key as well as the more traditional transactional signing, what are the 2 or 3 use cases that you believe that we can enable that would accelerate the adoption or make it more real to people? Because that's the one piece that dApps are missing. What do you see as the driving possibility space that DM3 opens up?
So I think there are several different use cases. So one use case is a dApp-to-dApp messaging, what you can provide for your users. Now, if you want to build an application, for instance, a marketplace or a wallet where you have different key holders in it, then it would be a very important thing that these can communicate with each other. Or if you have a gaming application, then you have in-app or in-game communication. And of course, these things exist. At the moment, mostly they are done with a centralized approach. But with DM3, it is very easy to include it in your application. Now, beside the protocol, we are also providing a set of, we call it embedded widgets, which you can add to your application with only 1 or 2 lines of code. And with this, you have a full-featured messaging functionality with all this security, privacy, all what you need in your application. And with this, you have a very unique way and very easy way to build this messaging functionality into your applications. So this is one use case. So another use case, what we think is really important, and I mentioned this several times before, is that we think it is very important in the future that the user can decide what messenger fits best for my needs without thinking, okay, is this messenger good enough that I can contact all the friends or my family or whatever I want to contact? So, and this is, I think, the most important thing we need to accomplish in Web3. And then, maybe export it to the Web2 world. So in Web3, we have a lot of different messaging protocols and applications appearing in the last year. So,
and more every day, it seems like.
At least every week there is a new one popping up, and most of them are really good. And they also have special focus for their special community. And it is good to have this diversity, because a one app fits all, I don't believe is a good approach. Because someone needs a very lean messaging application. Another one wants a messaging application where he has some news feeds in it, or he wants to connect to a special community, have a token gated access, and whatever. So there's no one app fits all approach which really can work. So, and with the approach to being interoperable, we don't need this. The user can decide what is the best fitting tool for me. And then, if this tool is DM3 compatible, it can look up in ENS registry to any other contact and can send it to this other contact. And if they are using the same approach or the same tool, of course, this could be an internal communication. If they are using another tool, then they can use the DM3 protocol and bridge it to any other network. And when we think about the Web2 world, So at the moment, of course, they are very siloed. No? We have these different tools and they have no interoperability at all at the moment. But at least here in Europe, there are some things in work so that the regulation will enforce that these messenger also needs to be interoperable with others. And of course, this can be done in a lot of different ways. But when you think that a centralized service offers, okay, all others can use my infrastructure to be interoperable, this will not work. The others will not use it. With dm3, we have a decentralized approach which can use by other decentralized protocols, but also by centralized protocols to be interoperable with others. And with this, we think there is a really good approach now available which can solve this problem that messengers need to be interoperable.
Yeah, it's interesting to think of ENS as the kind of the profiles of profiles, a link tree that you can read right to that allows people to say, hey, I am these identities on WhatsApp, Facebook Messengers, and Discord, and then declare that as part of your profile. And that's how the interoperability happens. So if someone sends you something and you happen to not share a network, then they can say, well, let me send it to you in a Discord and somehow adopt an identity. I mean, federation is a hard problem because the other person needs to either have an identity or have a key, and making the Ethereum wallet a dependency is its own challenge, but maybe there's a way through account abstraction. And again, I think that's beyond the scope of our thing where we can just give people some kind of temporary accounts to use.
Exactly. There will be different ways, and maybe also some Web2 services will offer a custody solution for their users. Right? Of course, if I'm using a Web2 messenger, I don't have a connection to my wallet. But to be interoperable with dm3, of course, they need these keys. But in these cases, a custody solution could be also a solution to add these services to this network.
Yeah, it would be very nice if the big tech company end up being good wallet provider. We see some third-party services that were like, hey, if you log in using Google, I'll give you a key. But then that's another third party sitting between you and Apple. I would love if Apple give me a Web3 compatible Ethereum key to use as part of my keychain. That would be fantastic. And if they integrate it into my my secure enclave, my phone, I would trust it a lot more than some React Native implementation of such user space encryption. So and that would be a nice thing to aim for. But I do see your point that a lot of the tools that we would need to bring the Web2 space in interoperability actually is experimented with and exists in the Web3 space. Even though people think of WebSpeed as some spin-off from Web2 that is not going to deliver any value, but we're actually solving some of the coordination thing that even the Web2 people wasn't able to do. And if we successful in that, it does pave a way for them to plug in their user space and their product development expertise into a coordination mechanism that we hopefully will have perfected by that.
Exactly. Yeah, so that's why we say, let's start in the Web3 space, build out this technology, using our ecosystem to show that it really works and that we can provide interoperability. And then, spill out to the whole world. So, because then, if it's proven in the Web3 world, it can be extended to the Web2 world as well.
Absolute thing. And I think this idea of bridging between Web2 and Web3 is not really about, everybody's going to integrate like financial product into their stuff. I think we are starting to see that the infrastructure of Web3 is really a general set of tools that just, solves a set of problems that we may be trying to solve with SMTP and POP3 in a new way. And that now becomes a modern stack that can integrate with very consistent. And as the tooling in the industry gets better, like signing, for example, is a good way of doing financial transaction, but it's also a good way of doing approvals for organization. And we start with DAOs, but how's any corporate decisions all that different than that? So there might be an opportunity to use the same set of primitives of smart contract wallets and approval limits for corporate governance. And that's the stuff that excites me. I'm a Web3 technology that spent quite a bit of time in the corporate world and understand how broken those processes are and hope that the tools we're inventing here can actually help provide a migration path onwards.
There's not much to add to this.
Yes, absolutely. Well, This was really illuminating for me, and I think we were able to. I have your how DM3 works diagram in front of me, and I think I'll post a link to in the description on YouTube. People can take a look at it. It's really good documentation for developers, for regular users, and for people interested in the architecture. And then again, we're adding to the architecture stack of Web3. We call it land of the Web3 because it's like a really wide array of solution. It's not really just the perceptive that this is just NFT and trading. It's really about a set of web adjacent or web enhancing solution that at its root is thinking about the protocol design that we started with the internet and RFCs in the original era of RFC 822 would be the email protocol. Like we're adding to that, we might call them EIP, we can call them CSCIP, whatever it might be. It is still within the same protocol design that I think is an art that we lost. We thought that a giant computer in a Facebook data center can do everything, and we're starting to see that, hey, maybe we should think about this as a network of computers. And thank you for adding your particular insight into this field. And this sounds really good.
Yeah, thank you very much. And also, we think that that's why we started. We call it the Messaging Interoperability Initiative, which had the goal to bring together all messaging providers, of course, from the Web3 world, but nobody is enforced not to be there. Of course, also Web2 providers are invited, so that we can define what is really needed to make this possible. And we now are starting to build or to connect to protocols. So there are some implementation in work right now. And we hope to see in some months in the future that we have a lot of different protocols which are now connected in this way to allow the user to decide what messaging he wants to use and nevertheless being able to contact all others.
All right, I think that's really good insight to talk about the important interoperability, and I'm definitely looking forward to see the integration of the different protocol and follow them on Twitter and other places. What's the best way to keep in touch with your project?
Yeah, there are some ways. You can follow us on Twitter with DMC Protocol. You can also go to our webpage. There are also other ways how to contact us. We have a common ground group where you can directly talk with us. Yeah, and of course, you can use our ENS names and directly contact us using DM3.
Right. Dog fooding your own contact, right? That is really fantastic. I think it's the community is going to be really interested to see someone take a different approach to add to the diverse conversation. I think these things will all work together very well in the future because the idea that the core infrastructure and cryptography. I mean, think about it. Ethereum successfully distributed public key and private key infrastructure in the way OpenGPP or PGP in general didn't do. So we really can build on top of that that distribution that is already available and proven at scale. Maybe not in the same use cases, but I think it's adjacent and it can happen. Yeah. So thank you so much, Stefan, today for your conversation.
Yeah, thank you for having me. It was nice to be with you.
Absolutely. And as always, a community, we do this every 2 weeks to highlight these new developments that's going on. And it's really exciting to have you guys join us. And until next time, take care.